first start with the preliminary test. Wash all the apparatus with water. Test 1. Let us find out the nature of the salt. Take a pinch of the salt in a test tube. Add about 1 to 2 cm cube of water. Shake well. Has the salt dissolved? The salt has dissolved in water. This shows that the salt is crystalline in nature. Observe the color of the salt. The color of the salt is white or colorless. The salt may contain aluminium, barium, strontium, calcium, ammonium, zinc, magnesium or lead radical. B. Let us now perform the dry test for cations. Test 1. Heating in a dry test tube. Take a small quantity of the given salt in a dry test tube and heat it in oxidizing flame for 1 to 2 minutes. Observe the changes taking place. There is a white residue at the bottom of the test tube. A white residue indicates that lead, aluminium, zinc, calcium, strontium, barium or magnesium radical may be present in the salt. Test 2. Charcoal cavity test. Make a shallow cavity on the surface of the charcoal. Take a pinch of the salt. Add to it a pinch of solid sodium carbonate and a drop of water. Mix it properly. Fill this salt in the charcoal cavity. Hold this charcoal piece with a pair of tongs. Using a blowpipe, direct the reducing flame on the charcoal cavity to heat the salt in the cavity. Observe the changes taking place. A white infusible residue is obtained. This indicates the presence of aluminium, barium, strontium, calcium or magnesium radical. Test 3. Cobalt nitrate test. Add 2 drops of cobalt nitrate solution to the white residue obtained in charcoal cavity test. Hold the charcoal piece with a pair of tongs. Using a blowpipe, direct the reducing flame on the charcoal cavity to heat the salt in the cavity. Observe the color of the residue. There is a grey colored residue. This indicates the presence of barium or calcium as one of the radical. Test 4. Flame test. First, we shall clean the platinum wire. Dip the platinum wire in concentrated hydrochloric acid. Then heat the wire in a slow oxidizing flame. Now take a pinch of the given salt. Add a few drops of concentrated hydrochloric acid to moisten the salt. Dip the clean platinum wire in it and hold it in the outer part of the oxidizing flame. Observe the color of the flame. There is an apple green color to the flame. This indicates that the salt may contain barium radical. Test 5. Borax bead test. This test is performed only if the salt is colored. As the given salt is white in color, we shall not perform this test. Test 6. Test for ammonium radical. Take a pinch of the salt on a piece of filter paper. Add a few drops of dilute sodium hydroxide solution on it. Fold the paper and smell it gently. There is no characteristic smell of ammonia gas. This shows that ammonium radical is absent in the salt. After performing the dry test, we conclude that the probable radical present in the salt is barium radical. Now, we shall prepare the original solution of the salt to perform the wet test. Take a pinch of the salt in a small beaker. Add about 1½ test tube of water to it. Stir the solution. The compound dissolves completely to form a clear transparent solution. This is called the original solution. Now we shall perform the wet test using this original solution. Basic radicals are classified into 6 groups depending upon their reactions with specific reagents. With these specific reagents, cations form precipitates of their salts with specific colors and solubilities. Test 1. To detect group 1. Take about 3 to 4 drops of the original solution in a clean test tube. Add 3 to 4 drops of dilute hydrochloric acid. Do you observe a white precipitate being formed? There is no white precipitate formed. This shows that group 1 is absent. Test 2. To detect group 2. Test A. Take about 3 to 4 drops of the original solution in a clean test tube. Add few drops of dilute hydrochloric acid. Warm the solution. Using Kipp's apparatus, pass hydrogen sulfide gas through the solution. Do you observe a colored precipitate formed? There is no colored precipitate formed. This shows that group 2 is absent. Test 3. To detect group 3A. Take about 3 to 4 drops of the original solution in a clean test tube. Add a pinch of solid ammonium chloride and stir the solution. Add concentrated ammonium hydroxide solution till alkaline. Test the solution with red litmus paper. The paper turns blue, indicating that the solution has turned alkaline. What do you observe? There is no precipitate formed. This shows that group 3A is absent. Test 4. To detect group 3B. Take about 3 to 4 drops of the original solution in a clean test tube. Using Kipp's apparatus, pass hydrogen sulfide gas through the solution. Do you observe a precipitate? There is no precipitate formed. This shows that group 3B is absent. Test 5. To detect group 4. Take about 3 ml of the original solution in a clean test tube. Add a pinch of solid ammonium chloride. Add concentrated ammonium hydroxide solution till alkaline. Check the alkalinity using a red litmus paper. A red litmus paper turns blue under basic conditions. Shake the solution well. Now add a few drops of saturated solution of ammonium carbonate. There is a precipitate formed. Therefore, group 4 is present. A white precipitate indicates the presence of calcium, barium or strontium. Use the original solution to further analyze group 4. Analysis of group 4. Take a few drops of the original solution in a test tube. Add a few drops of potassium chromate solution. There is formation of yellow precipitate. Take a small amount of the precipitate and add a few drops. Shake well. The precipitate is insoluble in acetic acid. This indicates the presence of barium. Confirmatory test for barium. Take small amount of the original solution in a clean test tube. Add a small amount of dilute sulfuric acid solution. There is a formation of white precipitate. This confirms the presence of barium radical. Flame test of the salt has already been performed. It has shown an apple green color. This further confirms the presence of barium radical. Now, let us tabulate the result. The given salt contains a barium as a basic radical.